Today, the conversation has shifted to inference. Inference is becoming the dominant workload, and with it comes a new focus on economics, utilization, and performance. Multi-tier architectures that combine flash, object storage, and disk-based capacity tiers are emerging as a key strategy for controlling costs while maintaining performance.
It doesn't work to put everything all in NVMe on the highest performing thing that there is. So how do we optimize that? And what are the options around that?
For AI training, it was mainly a throughput problem. How many fast SSDs could we get lined up with a parallel file system, something like Weka? But when we look over to inference, the requirements are really around latency and IOPS. If they don't, you have to recompute, and that translates to wasted GPU cycles, higher infrastructure costs, and to the end user, more latency. And so from a storage point of view, this is very exciting because now storage is really much more of an active player in the inference pipeline.
Most enterprises want tier one performance, but they really are looking at it. They don't want to pay tier one costs for everything that's going on with that.
It's not just about offering data at the peak performance. It's about optimizing storage as it moves through the different tiers and having the optimized performance throughout the full AI data pipeline, at each stage. If you're optimizing just the hot tier or the compute tier, you're not optimized. And so that money that you can be saving can be reinvested into different components, into GPUs, into the higher performance storage architecture or compute components as well.
When we look at the topology for customers is that life cycle, when you're talking about tens or hundreds of petabytes or even exabytes, it's not all going to live in flash. It's going to have some type of progression or life cycle. How do we really maximize that high performance requirement and use the appropriate storage media and hardware to go from there all the way down to cold offline storage in a cohesive and policy-driven way?
Storage is sexy again. It makes so much sense because not every workload is equal, especially when you get into agents and things of that nature, from file to object to flash, CPUs and GPUs and hard disk drives.
AI-ready storage is not just about faster drives. It's about tightly integrated compute, intelligent data management, and a strong ecosystem.
You have to partner, and this is one of the great things about the panel having Weka and Scality together, showing that, hey, we can all work together to deliver the values that people are looking for. Also, one of the things we see with our customers is there's usually this whole factor of they don't really know how quickly this storage is going to fill, and if they don't have tiers, then they're going to be buying more all flash.
As agentic AI becomes more integrated with enterprises, there's going to be more value with the data that you have. And so I think from the outset, there needs to be a very strong strategy around how do you manage data, how are you going to store your data, and to also not just consider compute as kind of the first tier citizen, but also storage now is just as important. And so come at it with a holistic mindset on how you're going to get the most out of your enterprise data.
I think we've cut through the different layers of the multi-tier cake here and really shown people different things that they can take away and help them understand that, to your point, Paul, really do their homework. So thank you all for coming on board.